first, again, we're going to use algebra here. And I said it a minute ago, but we're going to multiply this by itself.
Wow.
So we're going to multiply secant minus tangent times secant minus tangent. Can't write it that fast, but...
Oh, no, I did that right.
And notice that I'm doing everything on this side, and I'm going to end up with what's on this side eventually. We're going to use FOIL again, or the distributive property. So first times first is secant squared, yeah? The outside is negative secant tangent, and the inside is negative secant tangent. So what's negative secant tangent and another negative secant tangent? Negative 2, right? Negative 2 times secant tangent. Yes, I call it FOIL, but yes, secant tangent. So I'm not really going to review what it means to distribute right this second, but I will on the board later if you need me to. And then the last times last is positive tangent squared. And right about now I want you to get out or to make sure you have your identity sheet handy, because I have a question. Yeah?
Why did you keep secant and tangent together in the middle?
Well, I said I wasn't going to do it, but I'm going to write it on the board right now instead of using room right here. Because of FOIL or the distributive property, however you want to say it, when you multiply, let me just write this really fast, secant minus tangent times secant minus tangent. And I'm going to use the acronym FOIL. Yeah, I'm listening. Yeah. First times first is secant squared, yes? The outside is what? Secant times negative tangent is negative secant tangent, yes? The inside is also negative. Can I say negative 1 times secant tangent? And negative 1 times secant tangent, right? Negative 1 times secant tangent and a negative 1 times secant tangent is negative 2 times secant tangent.
So you put the 2 right there, right?
Yeah. I did that part in my head a little bit.
I did it a different way.
I
don't think I did. I think I did it wrong.
That's okay if you did it different. Let me finish this way, and then we'll explore some other ways as well. Because there's probably like 20 different ways to do this. Okay. So I was saying, did everybody get their identities ready? I have a question. The answer's on your identity sheet. It's close to that. What identity has secant in it? Let me give you a hint. I'm talking about a reciprocal identity.
That 1 over cosine?
Right. So secant squared, if secant is 1 over cosine, then secant squared is 1 over cosine squared. Very good. This is 1. And does everybody see how I got that from the identity sheet?
Nope.
You don't? All right, I'm going to show you. So on your identity sheet, right here, I can't blow this up, but look on your sheet. It's this one right here. Do you see that on your sheet? Right? Secant is 1 over cosine, right? So does it stand to reason that secant squared then is 1 over cosine squared? Okay, good. Now, tell me please, well, we already said it before. I'm going to put a fraction here. Isn't secant 1 over cosine? I'm going to put the cosine here, right? I'm not going to put the 1 here. Is that okay with everybody? And what about tangent? What's that on the identity sheet? And I'm talking about a quotient identity. What can we use for tangent? What can we write instead of tangent from your quotient identities? I heard that. Very good. So I'm going to put sine over cosine. Yes? And
Plus cosine x, or?
no, that's a times. That's a dot. Sorry. And what about tangent? What again, a quotient identity. What quotient identity does tangent have? Sine over cosine. So tangent squared would be sine squared over cosine squared. Over cosine squared. All of these come from where? From your identities. Yeah? What's another way to say or write cosine times cosine? Of course, I'm going to write that here. So I have 1 over cosine squared minus this 2 sine still over cosine squared and plus this sine squared over cosine squared. Don't I have a common denominator here? Of course.
Right.
Right. I can write it as one denominator. Cosine squared. And my, don't walk in front of the screen, please. Okay. That's all right. All right. Actually, that doesn't matter because it doesn't record on here that way. I wasn't thinking. All right. So forget what I said. All right. So what will my numerator be? 1 minus 2 sine plus sine squared, yeah? 1 minus 2 sine plus sine squared. So I'm going to ask you again, well, I don't think I said it as a question before, but what I said before is we have to recognize when we see it a difference of 2 squared. This is not quite the same thing. This is another special type of expression. What other type of expression did you learn to factor besides the difference of 2 squares? It's okay if you don't remember. What else did you learn to factor that was, I'll call it special, besides the difference of 2 squares? This is not a difference of 2 squares. This is another one of those special types of expressions. How about a perfect square trinomial? You guys know what I'm talking about? A perfect square trinomial, we have to recognize it or check for it by checking these two terms and then the product of twice that. So is this a perfect square? It's 1 times 1, isn't it? Is that a perfect square? Yeah, it's sine times sine. And then we take sine times 1, multiply it, and then double it, and do we get what's in the middle? Yeah, we do. Forget about the sign for a minute. So this factors, I'm going to review the factoring part here in a second, but on the board after we're done. I'm going to review why this factors. When we break this down, when we factor this, again, factoring is just a way to write something in a simpler form. It's 1 times 1, and sine times sine, sine of x times sine of x. And if it's a perfect square, that means these are both the same. So they're either going to both be pluses or both be minuses. What do you think?
1 minus 1 squared.
No, that's when we have a difference of 2 squares. This
Both
is
are negative.
both are negative because that's a negative, right? So, and on the denominator, we have cosine squared, yes? Okay, cosine squared of x. All right. Now I want you to, if I have room, look on your identity sheet. I'm just going to show you where it is. On your identity sheet, we have this identity. It's in your Pythagorean identities, and it has cosine squared in it. Which one am I talking about? Which of these three? Well, it's obvious. The first one, right? Sine squared plus cosine squared equals 1. I'm just going to write on this paper. I know that's small here, so I think I'll write it on the board. So I'm talking about this first Pythagorean identity. Please say what it says, everybody.
Sine squared
Plus
cosine squared
is equal to 1. We've used that how many times so far? A heck of times, right? So I want you to be familiar with that. You know what I know is to practice it. So I'm going to write what we just said, that sine squared plus cosine squared. What's it equal, everybody? What did you say? That's fine. So my question is, we need to have cosine squared by itself, don't we? What could we do to this equation to get to this identity or equation to get the cosine squared by itself? They've added sine squared, so we could subtract sine squared, couldn't we? And don't we then get that cosine squared is equal to 1 minus sine squared? So whenever we see cosine squared, what can we write instead?
1 minus sine.
And where did we get that from? From the identity sheet. I'm going to write what you just said, Arturo.
So you expect us to memorize all of these?
How many times did I say that? Yeah. And I don't even like the word memorize. I expect you to be very familiar with them. I expect you to know them well, and you know how you get to know them? By using them. Guess what we're doing? We're using them. Every problem, we're using them. Aren't we?
Yeah, but it's because, like, it's like like a lot of breaking down
Yeah,
and switching it and filling it in.
Mm-hmm. And you will get good at it if you do what?
If you practice it,
That's what I'm talking about.
it's gonna take us a while.
And that's what we're here for.
Like
How long did it
months,
take you, Mr.
It's
Bob?
not gonna take a month.
Huh?
like a month probably.
No.
How long did it take you?
I'm never done. I'm always. What's that?
Be honest.
Well, actually, I didn't take trigonometry in high school.
Oh, we don't gotta do this?
I didn't say that. All right. So we're going to replace this with 1 minus sine squared. We get 1 minus sine. 1 minus sine. I almost ran out of room here. Times 1 minus sine. And on the bottom, we're going to get 1 minus sine squared. So not my last question, but can't we also factor this? Isn't this a difference of squares? Right? It's 1 times 1 and sine times sine. So this is equal to, well, let me write the numerator first. We still have 1 minus sine times 1 minus sine.
Can't you?
And in the bottom we have, right, 1 times 1 and sine times sine.
One negative, one positive, right?
Very good. 1 positive and 1 negative, right? And then what can we cancel here?
One positive and a negative.
No, we can cancel out 1 minus sine and 1 minus sine, right? And what's left, everybody? What's left? This is what's left,
Our answer is
which is what we were trying to show, isn't it? And so we are done. And I'm going to stop the recording. That's a long one, but I want to address